Hello everyone. Our next type of channel is deterministic channel. A channel, a channel with only one and only non-zero element in every row, we call it as deterministic channel. So whereas in case of noiseless channel, we have seen that there is only one and only non-zero element in every column. So second one, we have deterministic channel. So it is having non-zero element, one and only non-zero element in every row. Such channels we call it as deterministic channel. So we have some properties of deterministic channel. That means the sum of all elements in any row must be equal to 1. So that means it should have only one element in a row and sum of all those elements should be equal to 1. So how can I represent such type of channel? Probability of B by A, that is channel matrix, is given by, if I'm having A1, A2, A3 as symbols, and let me take B1, B2, B3 as output symbols. So how can I represent? Only one element should be present in row. So obviously next element will be 0 because the sum of all the elements in a row should be equal to 1. So if 1 is present here, other two elements should be 0. So if 1 is present here, other two elements should be 0. So such channel we call it as deterministic channel. Okay. Next type of channel is symmetric or uniform channel. Symmetric or uniform channel. So this is a special channel such that in this channel the second and subsequent elements are same as that of elements of first row. That means if I'm having, let me take A1, A2, A3, output symbols are B1, B2, B3. If I'm taking the probabilities in the first row as 1 by 2, 1 by 3, 1 by 6. Second and subsequent rows will be having the probability same as the probability of first row. That means it should contain the element 1 by 2, 1 by 3 and 1 by 6, but the order may change. The second and the subsequent rows will have the same probabilities as first row with some, there may be changes in their order. So it is, let me take 1 by 3, 1 by 6, 1 by 2, or 1 by 6, 1 by 2, 1 by 3. So just observe the elements of the first row. Same elements are repeated in the second and third row, but it in a different order. So such elements are called as symmetric or the channel with such probabilities. Such channel matrix, we call it as symmetric or uniform channel. So how to write the channel diagram or noise diagram for this? A1, A2, A3, B1, B2, B3. So A1 to B1 probability is 1 by 2. Here probability is 1 by 3. Probability is 1 by 6. Similarly, A2 to B1 probability is 1 by 3. A2 to B2, it is 1 by 6. Here it is 1 by 2. Similarly, A3 to B1, it is 1 by 6. A3 to B2, it is 1 by 2. A3 to B3, it is 1 by 3. So this is the channel diagram for symmetric or uniform channel. Yeah. So next, next type of channel we have is binary symmetric channel and we have binary erasure channel. So what do you mean by binary symmetric channel? So binary means it is true. So binary symmetric channel is a channel which has two inputs. Binary symmetric channel. So this channel is having two inputs and it has two outputs. It is called as binary symmetric channel. So let me take an example of binary symmetric channel. Probability of B by A is given by A1, A2, B1. So let me take the probability of A1 to B1 as P bar, A1 to B2 as P, A2 B1 I will take it as P, A2 B2 I will take it as P bar. Let me tell you why I have written P bar and P. So how to write the diagram, channel diagram for this? A1, A2. I am having two output symbol, that is B1 and B2. So probability of transmitting A1 to B1 is P bar. A1 to B2 it is P. A2 to B1 it is P. A2 to B2 it is P bar. So suppose I am transmitting 0. In the transmitter side, if I am receiving 0 itself in the transmitter, then I will represent that probability as P bar. If 0 is transmitted, 0 is received, then the probability is P bar. If 0 is transmitted, if I am receiving 1, I'll write that probability as. Similarly, if I am transmitting 1, receiving 1, then it is P bar. If I'm transmitting 1, receiving 0, then its probability is P. So such type of channel we call it as binary symmetric channel. And next type of channel we have is binary erasure channel. This is the most commonly used channel in digital circuits. So here, whenever a symbol is received at the transmitter, it will just, if at all there is an error in the symbol which is received at the transmitter, that particular receiver will not receive that bits. Instead, it will send it back by considering it as a error bit. It will by the reverse channel. So that means whenever, if I'm having A1, if A1 is transmitted, if you are receiving B1, whenever it is P bar. P bar means if I'm transmitting 0, I should receive 0. Then only I'll write the probability as P bar. So if I'm not receiving the same symbol, if 0 is transmitted, if I'm receiving other than 0, then that we call it as error. So if I'm receiving an error, this bit will not be received at the receiver. Instead, it will be sent back through a reverse channel for retransmission. That means the receiver will not receive any error symbols. Any error symbol, instead it will be sent back for correction and then retransmission. So that means errors are removed. So we call it as binary erasure channel. In this channel, there will not be any errors which are received. So how to represent the matrix? Probability of B by A is given by, we have two symbols, A1, A2. B1, one is error and next is B2. So A1 and B1, same symbols are transmitted, then it is P bar. If any error symbol is transmitted, then it is represented as P. That means if I'm transmitting 0, if I'm receiving 1, it indicates it is an error. So P is the probability. A1 and B2 is not possible, 0. A2, B1, if I'm transmitting A2 but receiving B1, so that is P. If I'm transmitting A2, receiving B2, then it is P bar. And sorry, this is 0. If any error is transmitted, then that is P. This is how I am representing the channels. So we have seen different types of channels with some examples and their channel matrices. I hope you have understood. Thank you.